The next topic I will be covering here is engraving and its many applications where engraving can be used in different applications. So I'm going to go ahead and switch to an example to start with for engraving. One of the commonly used applications for engraving is for engraving text or curves or geometries of any shape. So as you have these curves created in your CAD system, or you could import them into your CAD. This could be text or a bunch of curves. As you can see, I have a combination of these in here. So to program engraving, we'll go into 2-axis and engraving and select curves as our geometry here. I'm going to just drag a window to select all of these. Right click and enter to accept our selections. So as far as the tool, you could pretty much select any tool type for engraving. So you could be selecting a ball mill, flat mill, corner radius. What's commonly or typically used is a V mill with a taper angle, which could be a 45 or a 30-degree taper angle, like an engraving tool. Or you could be even using any of these tool types in here, including form tools or custom tools. I will be covering how to define form tools later during our webinar today. So we'll specify the tool. We'll set our feeds and speeds, and we'll leave the clearance to automatic. Now we're over in the cutting parameters. You'd want to specify the location of the geometry. So if the curves or the text that you pick is at the top, you would say at top, and then you specify the total depth. So I'm going to specify the total cut depth as 50 thousandths, and you could break this up into multiple levels if you'd like to. So I can split it into 2 levels here, 25 thousandths each. And when we have multiple cut levels, we could specify the cut traversal between levels either to be zig or zigzag. So specifying zigzag will cut in reverse direction, meaning it goes in both directions. So it'll alternate between the directions for each cut level. And you can control your entry and exit. You can fit arcs to your toolpath in engraving as well. And we can apply a sorting sequence. So engraving can be generated for curves that are open and closed. In this particular example, we have a combination of both open and closed curves. And as you're seeing the cut material simulation, it's cutting it in 2 levels to a total depth of 50 thousandths. Now engraving can also be programmed for open curves and also curves that are not planar, like 3D curves. And I'm going to go through an example for that also in a moment. So if you'd like to run through the simulation here, you could always select the pause and then pick simulate to end to run through the simulation. So depending on the tool that is selected, you'll see the shape that's formed with the engraving. And with the engraving, the tool tip stays on the part region that you selected as your geometry for engraving. So I'm going to display the toolpath in hidden area so you can see the toolpath. So the tool stays on the geometry that you selected.
Yeah, so I just wanted to add one more to tie this back into the compensation discussion. So you can think of engraving as a toolpath method that does not compensate for the tool radius. All the other methods like profiling and pocketing, they actually take the tool radius into account and compensate by that amount. So the toolpath is actually off of the drive geometry by that radius. And that is by design. I mean, you are using the CAM system obviously for doing that. But in many cases, you don't want to compensate. You actually want to drive the cutter right on the toolpath, right on the drive geometry. And that's what engraving is used for. I hope that makes sense. Thanks, Uday.
Thank you, Joe. So let's look at our next use case for engraving. This could be used for engraving curves or text or any sort of geometry that does not have to be planar. So you may have a sculpted surface and have some text projected onto the surface, and we could use engraving even though the engraving is under the 2-axis methods, you will be able to follow along a 3D curve. So I'm going to go to engraving. We'll use select curves. I'll go ahead and select these curves in here. Now you may notice that we have a single stroke font. I'm going to show you how we can avail that single stroke font. We've developed a single line font, and you can download and install it onto your computer, and you can define text using single stroke fonts, and use the project command in Rhino to project those text onto the surface. And now when I specify a total cut depth in here, so I'm going to do a 50 thousandths depth, similar to what we did before. So it's going to maintain the same depth across the 3D curve geometry that you have here on engraving. So as you can see, the toolpath stays on the drive geometry and also maintains the XYZ varies as it follows the 3D curve geometry. So it's not resulting in a planar toolpath. It does follow along the 3D geometry. So this could be one of the very nice use case for engraving along sculpted surfaces as well. Now, a lot of our instrument makers, they use engraving for machining their fret slots. So, you don't have to model the fret slots in your CAD. Instead, you could actually just create those, three-dimensional curves or the arcs from either the XZ plane or the YZ plane, and use 2-axis in engraving, and just select those curves as your control geometry or the drive geometry, and then pick a tool for it. Now in this case, you could be even using an end mill if you want a 16th inch or an 8th inch slot, or even a ball mill. You could specify that. Specify your total depth in here. I'll specify 25 thousandths. And then we could still fit arcs to toolpath. So this would fit arcs in those principal planes, which could be XY, XZ, or YZ planes. And we now have our engraving toolpath for cutting those fret slots. So I'm going to run a toolpath animation in here, as I've not defined a stock for it, but you'll see it here. So it follows the 3D curve. So just to summarize, engraving can be used for programming open and closed curves. These curves could be 2D or 3D. You could be even selecting surface edges, not necessarily have to be curves. You could even pick surface edges from your solid surface geometry as your part region for engraving.